Hello everyone, this is the second lecture of week 13 where we come back to linear systems of differential equations and we will come back to normal form of such systems. Let me remind you that the normal form of system is the following. So we write the derivative of some vector function is some matrix function times this vector function. So x of t is some vector x1 of t and so on xn of t, and a of t is the matrix function a11 of t, which is square matrix a1n of t, an1 of t, ann of t. This type of normal form, this type of system is called homogeneous, and the system is non-homogeneous if we additionally have some another vector function here where f of t is a vector f1 of t and so on f. So this one is homogeneous, this one is non-homogeneous. And also, so let me maybe denote this one by 1 and this one by 2. And also, for linear systems, we may have some initial values, right? And for systems, the initial value will be also given by vector. So let's say we have some point t0, and x of t0 is some x0, where x0 is a vector, let's say x0, 1, and so on, x0n, where these are numbers. So linear system in such normal form with this initial value is called initial value problem. And for initial value problem, the first question that we ask today, do we always can find solution, and is it this solution unique or not? So let me give you the theorem, which is theorem 1. It says that if this matrix function and this vector function are continuous on some open interval I, which contains some point t0, then for any choice of initial vector x0, there exists a unique solution. X of t, unique solution, unique vector function x of t on this interval I to the initial value problem two, but let me write it one more time. So to this initial value problem. So this theorem says that if this matrix function and this vector function are continuous on some open interval which contains this t0, then we have unique solution. There exists unique solution x of t for this initial value problem. Of course, the next question is how to find this unique solution, and to this we will devote next videos. For example, let's consider the following system. The first step, we'll write the system in a normal form. So we denote x of t. This is vector function x1 of t, x2 of t. And the matrix A will be the matrix of coefficients. So the coefficient of x1 here is 2. There are no x2 here, so we have 0. The coefficient of x1 in the second equation is 1, and the coefficient of x2 is minus t. And also we see here additional functions which are without the multiplication by x1 and x2. So this will go to this vector function f of t. So this one is minus sine t and just 1 here. And so the system can be written as x prime of t is a of t for this matrix A, x of t and plus f of t. And the initial value are given, so x of 0, this is vector 3 minus 1, so this is that vector x0. And now looking at the theorem of existence and uniqueness, we call it theorem 1, there is unique solution for this initial value problem. And why there is unique solution? Because this a of t and f of t are continuous matrix and vector functions because they consist of continuous functions as their terms.